deriving index laws. In this session, we'll talk about how does index law 1 and 2 work. Okay. First of all, revising what is index notation. We said it is basically an abbreviated multiplication of the same number. So if a times a, then we write it into a to the power of 2. And a times a is written as a to the power of 3. So what if I give you a to the power of 2 times a to the power of 3, and you simply just multiply the indices together, and when you expand it, you notice it's actually, because they have the same base, it's basically 5 of the a's multiplied together. And from there, we notice a to the power of 2 times a to the power of 3 is essentially a to the power of 2 plus 3, because when you multiply the indices of the same base, you are basically connecting all the multiplication together. So the times that you need to multiply a is added together and becomes a to the power of 5. From there, you actually have the first index law. That is, when a is multiplied, when the same base is multiplied together, it equals to the same base to the power of their indices adding together. So a to the power of m times a to the power of n equals to a to the power of m plus n. Okay. Similarly, are you able to derive what if it's a to the power of m divided by a to the power of n? Well, because, again, index laws, index notation are written in this way. So if I say a to the power of 3 divided by a to the power of 2, then you basically have a to the power of 3 take away 2, that is a to the power of n. A to the power of 1. So the second index law is written as a to the power of m divided by a to the power of n. That essentially equals to a to the power of m minus n. Okay, so if you multiply two indices with the same base, it equals to the base to the power of the indices adding together. If you divide the same base, divide two indices with the same base, that equals to the base to the power of the indices subtracting each other. So let's see a few examples. Now, x to the power of 4 times x to the power of 5, then it should equal to, since they have the same base number x, x to the power of 9. Okay? So when you divide x to the power of 10 by x to the power of 2, then again, they have the same base number. It should equal to their index or their power, their exponents, subtracting by the first one by the second one. So it's x to the power of 8. Okay? Here, x to the power of 3 times y to the power of 4 times x to the power of 2 and y to the power of 1. Okay? Here, again, our index laws only apply when you have the same base number. So we sort of have to rearrange it a little bit to become, because x times x, so it becomes x3 plus 2, y multiplied by y, so it becomes y to the power of 4 plus 1. So in the end, you have x to the power of 5 times y to the power of 5. Okay, so index laws applies to the same base. When you have different bases multiplied together, you have to rearrange the order of multiplication so that you can add the indices of the same base together, multiplied by the indices by another base to the power of its own indices. Okay. The last one is basically C in a division mode, right? So for numbers, you got to cancel out using the highest common factor, which is between 8 and 12. Only numbers can cancel numbers, and letters can cancel letters, right? You can't cancel between numbers and letters. Okay. So numbers cancel numbers. A over 12 is essentially 2 over 3. Because they have a common factor of 4. And for letters, you use the second index law. So a to the power of 6 divided by a to the power of 2 is a to the power of 4. b to the power of 3 divided by b to the power of 2 is b to the power of 1. So then you have a cancel out 12, a because it's division, so you can write it as a to the power of 6 minus 2, b to the power of 3 minus 2, and then in the end you simplify it to this expression.